Hi, I'm Andrew from Verbotics and I'm here at Schweissen Schneiden 2025 along with our partners Admex and Entra. It's a bit of a slower day today, being Friday, so I thought I'd take you through a quick demonstration of what we've been showing with this robot system for those who weren't able to make it. So I'll go through the process of automatically programming this part and then generate and upload the code to the robot. So we start with a 3D model of the work cell you can see here, and first I will import my part, which is just a standard step file. You can see I have my beam modeled as well as some fixture blocks. So we don't want to weld the fixture blocks, but we do want to avoid running into them with the robot. So I'll click on these and select these parts are not weldable. And as you can see, they go grey. The next thing I want to do is create the weld seams. So to do that, we can either click on individual edges or we can run our automatic weld identifier. So this goes through, and with a single click, you can see we've identified every potential weld seam in this part. So I'll go ahead and click Add 72 welds to this project. For a real project, I'll then go through and assign different weld procedure settings, which you can do through the weld setting areas. And here we say, what is my optimum welding condition and what is my allowable range? And our software will automatically try and keep the weld process at the optimum, but automatically expand to the allowable range to avoid collisions, with no user input required. You can assign these settings one by one or by using automatic rules as well. It's based on things like material thickness or joint type. So once I've assigned my settings, I will start the automatic planning process. This goes through and first plans an optimized welding toolpath based on my weld process settings, including motion of the workpiece positioner to the PA position, as well as the external axis motions. Adds automatic sensing motions to account for the differences between the simulation and the real world, or from one part to the other. And critically, all of these sensing motions are planned automatically, so you can go straight from the simulated program to a ready-to-run robot program. We'll then also add all of the motions to move the robot from one weld to the other, as well as from home to home. So this process will take about 2 minutes on my laptop and is run all locally with no need to upload to an external server. So you can see the planning process is complete. So now we could watch this in simulation, but it's much more interesting to see it on the real robot system. You can FTP these programs straight to the robot from our software, but today I'll put it on a USB stick and then load it onto the Teach pendant. So now I'll take my USB stick and load and run the program on the robot. So now our program's ready to run. So you'll see the robot starts by approaching the first weld seam. It then uses a one-dimensional laser sensor to detect where the part is in real life. And that allows the robot to account for the difference between the 3D simulation and the real world without any need for manual touch-up or editing. And that's part of the magic that allows the program to go straight from the Verbotics software to a ready-to-run robot program, all with minimal time and effort.